Hello and welcome to Child and Adolescent Mental Health, Chapter 3. Let me move my big head out of the way here. All right, so for this unit, this chapter in particular, I focused a little bit more on science versus pseudoscience in light of what's going on in our country over the past couple of years. I thought it would be helpful to kind of point out some ways you can differentiate between things that you really need to know for the work that you're going to be doing versus things that might be fake news for the most part. Why can't I move this big head of mine out of the way here? There we go. Okay, so first, we're going to be covering how we know when we are dealing with false information versus valid information. We're going to cover some of the methods that we can look for to utilize this information. We're going to cover what the scientific method is, ethical issues around research and how that impacts research and outcomes, as well as how this deceitful, unethical sort of research can lead to dangerous outcomes, which is why we need to be careful about what we're doing. And also a quick overview around critical thinking. I keep trying to move this thing out of the way. It just does not want to go. Okay, I like to start with this nice little story here. I think it's kind of cute. The scientist was experimenting on frogs. He yells jump at the frog and the frog jumps 1 meter. He then cuts off the leg of one of the frogs and yells jump, and the frog jumps a 0.5 meter. He then cuts off another leg of the frog and yells jump, and the frog jumps a 1/5 of a meter. Then he cuts off a third leg, yells jump, and the frog does not jump. He yells jump. Again, the frog does not jump. Aha, he says. I have my result. So he carefully writes in his lab book, when 3 legs are removed, the frog becomes deaf. So you can see the purpose of that little story was to give you an idea of when we're looking at research, we have to be very careful about what it is that we're measuring, what we're looking at. And that goes for reviewing other people's research. It's unfortunate that we need to do this. However, what we do know is that there are a lot of opportunists out there in the world. And sometimes what they do is they try to take advantage of certain scenarios. Hence this article on snake oil salesmen. And it's kind of an interesting, if you read the background of this whole term of the snake oil salesman, if you look at the background about Clark Stanley, you'll see what all this means. He was using rattlesnake oil to sell a product so that people would think that they could be cured of all kinds of things, from toothaches to sprains to insect bites. And it's kind of an interesting background as far as what he did. It wasn't just that there was snake oil in it. I mean, eventually there was I think no snake oil in it, and it was just some combination of opium and alcohol, which would certainly make anybody feel slightly better if they're in pain. Other problems in research have to do with, and you can kind of see this in other areas as well, but trying to stick to psychology a little bit. Peter Neubauer was a psychoanalyst who was very interested in looking at the nature versus nurture debate. And after he escaped Germany during the 40s, when the Nazis were taking over, he was involved, I think it was New York, he was involved with an adoption agency, and they worked out a research project where they would split up twins, and in one case triplets, and send them to different homes. and meet with them every so often to review their progress, how they were doing psychologically, emotionally, etc. Um, the downside is that they didn't tell the kids what they were doing. They didn't tell the foster parents what they were doing or the adoptive parents what they were doing. And it turned out that some of these kids, they came from a genetic background where there was significant mental health issues. The movie itself, and this is the nature nurture. If you're not familiar with that is, in most abnormal psych classes, you'll see there's this overlap between the two that we discuss and debate. But the movie itself is called Three Identical Strangers, and I just have a highlight of it here. But you should look it up. I can't remember if it's on Hulu or Prime. But he took this set of triplets and split them up, and they just by coincidence found each other, and it turned out to be, kind of a mess at the end. I believe one of them committed suicide. There were a lot of issues that they had at the outset, but then their environments were obviously manipulated by Peter Neubauer and the agency, where they were put into different homes. And I think that the young man who ended up committing suicide was placed in a home that had a very poor resources, family conflict, all kinds of stuff that led to what we call adverse childhood experiences, on top of whatever genetic loading he had going on. Oh, didn't mean to play it. Fast forward here. So what came out of this research that we found was that all biological parents appeared to have some sort of mental illness. No one was given any sort of informed consent. And they never were even told that they had siblings, which is really quite a shame. A lot of families hurt as a result of this research. Other areas of research that have been problematic have to do with vaccines and autism. There's been this controversy around vaccinations, not for the general scientific and medical community, but for fringe communities, fringe groups, as a result of a fudged study by Andrew Wakefield, where he basically changed his data and tried to show that the MMR vaccine had a direct link to causing autism. A big problem with all of this was that, aside from changing his data, which is unethical, it led to a lot of health issues as well. Chickenpox outbreaks, outbreaks of other illnesses where people got very sick, died, because they were buying into what he was selling, which was inaccurate. In fact, his co-authors all recanted the paper. The paper was published in a journal called The Lancet, and The Lancet even pulled the paper. Wakefield ended up losing his license, but he still goes around saying that the vaccine, because this is kind of money making at this point for him, the vaccine causes problems, and for whatever reason that has taken hold with a group of parents who are very concerned about why their kids would develop autism when they seem to be developing just fine until they hit somewhere between 2 and 3. There has been a lot of time and effort gone into trying to replicate his study. It has not been able to be replicated. In fact, most times when they've gone back to try to check the numbers connecting MMR vaccine to autism, you generally see higher rates of autism in kids who are not vaccinated, which is a little bit different than what you might think. The other interesting thing about this anti-vaccine movement that's still going on is that honestly, vaccines have been like the most successful public health intervention that we've had to date. It's helped us live longer and healthier lives over time. In fact, Native Americans knew about vaccines. They used a method of inoculating others. So it wasn't like it was something terribly new, but it is kind of interesting. I do have a link, I think, at the bottom of the unit about the history of vaccinations, where they sort of came about. Another area of research where it had gone poorly is the Tuskegee syphilis study. You may have heard of this, where I think it was actually some part of the government. It might have been the CDC. I can't really remember. I have to double check. A researcher from that department was assessing the outcomes of syphilis over time on a population. Well, what they did was they targeted a population that was oppressed, impoverished. They kept information from them, and they just kind of watched them die over time from this illness. And you can see why, after having done something like this, and it wasn't terribly long ago, in the span of things, it wasn't terribly long ago, you can see why there would be distrust of government agencies when this sort of stuff was let happen. So let's talk a little bit about this idea of research and why we come to think there's research out there that's helpful or true, when in fact the method of the research is what makes it not exactly what we would call within the scientific method. So, for example, Freudian theories, Freud, his work, he would often, he developed this theory, right, of the psychosexual development. The whole oral, anal, Oedipal. You guys have probably heard those stages. So what he would do, he came up with this theory, and then what he would do is when he'd work with adults or even children, he would sort of retroactively fit in their stories to his theory, so it fit all nice and neat, right? So it's like you can't really disprove his theory because he's saying that the person in front of him is the outcome of his theory, but there's no testing the theory along the way, which doesn't really prove the theory ultimately. There have been many other historical research abuses, which is why there's all kinds of regulations when it comes to specific populations in particular. The Nazi human experimentation on prisoners of war, on Jewish residents who were all sort of crammed together and then later put into concentration camps. They were first put into ghettos. South African experimentation on electroshock aversion for homosexual men. We know that doesn't work and pretty unethical. The Stanford prison experiment, chemical weapons experiments on GIs, and experiments on children as well. And there's other examples of it that you could find if you took the time to look. So what's the difference between science and pseudoscience? Well, in science, we can see that a hypothesis can be falsifiable, unlike in Freud, for example, where you can't really say that something's wrong because you can't go back and test what's already happened. Science seeks out alternative explanations, looks for evidence beyond face value. Science can be replicated. So if I'm doing my research, I publish it, I have all the details there, someone else should be able to pick that up and get something similar to what I've been able to come to as far as a conclusion is concerned. Data is not messy. It's collected carefully. people are other colleagues are able to look at how I've done my work and kind of tear it apart and determine, what parts I did right or wrong, or if there are other questions that come up as a result. It's ethical in its methods in that it offers informed consent to people so they know what to expect. They know how to get out of the study if they don't want to. And it doesn't just rely on anecdotal evidence. What I mean by that is like, hey, my cousin's nephew, his neighbor got a shot last week and then they turned into a zombie. That sort of thing. That's anecdotal, right? That's not hard data. Pseudoscience tends to rely on exaggerated and contradictory claims with little evidence to back up those claims. They rely on anecdotal material. You'll find that their research cannot be replicated. If you think of Wakefield, his research could never be replicated by anybody else, which shows that there's a problem with the methodology and the outcome. They will hide information or data or methodology so that others cannot evaluate it. They will focus on existing bias because it's easier to buy into something if you kind of think that's how it is. They don't look for other explanations, and the data is not clean in its collection. So, for example, this is the steps of the scientific method. You'll start with an observation where you'll see something happen. And then you'll come up with a question, a research question. You'll put forth after that question a hypothesis. In this instance, we're comparing different bags of fertilizer. At that point, if you're doing this comparison, then your hypothesis can be challenged, right? So if you're hypothesizing that fertilizer A will grow things the fastest and it turns out to be C, then that means your hypothesis can be rejected, right? So now we're showing that whatever bias you have or whatever your idea is open to the possibility of being rejected. You look at the results, you come to the conclusion. In addition to this, I'd like to point out that in research, what they often do is at the end of all these research papers, you'll see areas of limitations or limitations of the study, where they will list parts of the study that they think could be carried on by others, areas that they know maybe don't get at the full answer because some part of it couldn't be completed. And so they'll also go over those aspects of it as well towards the end of the study as they're summarizing things. In terms of what is the most, closest to true that we can see as far as the study is concerned, this little pyramid will give you an idea of how that works. So expert opinion, that is at the lowest form of scientific evidence. So an expert's opinion, right? You can't just go off of what someone says. It's helpful, but next step up is a case study. So actually working with a case that you're researching, observational study, seeing what's happening in front of you, experimental study, and then last is a systematic review where you're looking at many studies and kind of coming to a conclusion based on the overall outcomes of many studies. That gets you closer to what you might call the truth. Now, science will never say it's ultimate truth, right? They're always going to say that there's some possibility for change because there are things sometimes that we just don't know, right? So science will say that more than likely or 90% chance or something like that. There's always some room for the possibility of change. That's just how science is. The other thing that happens in methodology is sometimes we mix up correlation versus causation. When we see a coincidence of things happening around something, for example, with Wakefield's study, in terms of correlation, what often you'll see is that in that 2 to 3 year old development, that is at the time that kids are getting their MMRs. I think it's 18 months exactly, right around there. If they're getting their MMR vaccines. Well, what's interesting developmentally in terms of our bodies and our biology and all that, that is right around the time that we might start seeing signs of autism. So One does not cause the other is the idea here. So the MMR vaccine does not cause the autism. Rather, the MMR vaccine is given at a time when you might see autistic features. So I use this simple example. Oh, hang on. Sorry, wife's cooking. So you're woken up by a rooster every morning when the sun comes up. Hey, the rooster crows, the sun comes up. Oh my God. So maybe the rooster causes the sun to come up. Well, that's causation. That's saying that one causes the other. But instead, what we're looking at is correlation. Sorry, there's a little distraction around here with dogs and fire alarms going off. So really what we're trying to see is there a direct tie from one thing to another? Is the direct tie between MMR vaccine and autism, or is there causation there, or is it just correlation? Does one happen to happen around the same time as the other? You may just be seeing these two things, separate things, happening around the same time. Other things that we have to be aware of with regards to ethics are informed consent, making sure that the client and anybody involved knows all aspects of the interventions, what sort of testing, how the data is going to be handled, confidentiality, all that sort of stuff. The Stanley Milgram experiment led to the IRB, internal review boards at universities and hospitals, making sure that human subjects are protected. So like in particular, there are very vulnerable populations like prisoners, children, pregnant women. There are very specific populations where you have to be even more careful with how you're using research. And an IRB is a group of people, a board, that will look at what you're proposing to do, and they will say, no, I think you need to let them know this, or we don't think you can do this because you're putting people at risk. So they help kind of determine what's okay and not okay as far as your research is concerned. The other thing is we have to know what our limitations are of the testing and make sure that we are accounting for those sort of things and not jumping to conclusions that one thing leads to another. There is also bias in research. If you're going into a research study with an idea already in your head, you have to be aware, you have to be open to the possibility that you're wrong or that you are incorrect, right? And that's kind of what you want. You want to see if you're, and if you are wrong, that leads to other questions, right? So you can continue your research. That's the idea here. Is we're trying to get to what a closest to true answer is. A scientist would never say true per se. But another piece that comes into play with this, as far as research and what sort of material you're going to be reading, has to do with critical thinking. And when it comes to critical thinking, that is connected directly to how you interpret, analyze, and evaluate the claims that are being made, the explanation of things, how your method of reasoning comes about. All this sort of stuff needs to be out and upfront so that others can critique and guide the research, shape it. Oftentimes what you'll find in the research community is that people will pick up on others' research and continue it to the next step or next steps in answering questions. So research never really quite ends, it keeps going, which is why I say that science never really says like ultimately like true, right? The closest to truth that we can get is more like it. So let's think about this. I threw out a lot about stuff out here. How do we apply this stuff when we're thinking about research? There are questions when you're reading a paper or you're getting information that you need to kind of consider. Those questions are like, what is the author trying to examine? What do they want us to know? How do the research findings answer that question? How does the author look at other explanations to the question? Are there other researchers out there that are looking at this, and what do they think of the methodology and design? How does the author address other questions that arise from the research? What's the source of the information? What's the reputation and the credibility, and what are their motivations behind it? Um, what's the author think the information will do? Does it need more investigation? Oftentimes, at the end of a research paper, they'll say like, and for further, this area needs further investigation, and that part is important. And ultimately, has the author allowed colleagues the opportunity to review, comment, or revise or replicate? Because that's really where the rubber meets the road. Can this thing be replicated? What are the outcomes? Are they similar? Are they different? And why would that be? Now, you can also turn this into the work that you do with others, right? This critical thinking piece. So let's go through that. A 7-year-old boy is sent to a principal's office for running out of the classroom. The boy is not clear as to why he does this, but it happens at least once or twice a week. So the questions you might start off with as you're trying to investigate the cause here, maybe doing some applied behavior analysis sort of work, is you're going to try to look at what the patterns are of the behavior. And that includes a lot of things: time of day, with whom, under what circumstances, how much sleep did they get, what room are they in, what teacher was working, etc. What is the possible purpose of the behavior itself? What function does it serve? What is the point of the behavior? What are all the possible reasons for the behavior? What are the theories involved in it? What is noticed about the child at that time in terms of their affect, physically, nonverbal? What's their home situation like? Kids sitting near him. And how are things different when he does not run out of the classroom? And why would he stay versus run out? So this critical thinking component, these questions that you have to ask, also come into your clinical practice. Just like you would apply in research, you have to try to determine really what the purpose is and other alternatives, really to try to get a broad range of answers to kind of distill it down to your best possible answer. The end.